Hey guys, it's Mrs. Dewar from Making Algebra Fun. Today we're going to look at solving systems of equations by substitution. So we already looked at how to graph systems of equations and get the solution, and if you don't understand that, check out my video on solving systems of equations by graphing. Can you think of any reason why the graphing method may not be the most efficient way to find the answer? So recall that when you're given a graph, you're looking for the point of intersection. And a graph like this would be great because it's perfectly drawn and you can see exactly where they intersect, and that would be fine. However, when we're doing this by hand, it's not always as easy to see exactly where they cross, sometimes just due to human error with squiggly lines or lines that aren't perfectly drawn. You can see that it's difficult to find out where that solution may be. Another issue is even if you were to graph them perfectly, sometimes they don't turn out to be integer solutions. And so when you graph them, the intersection ends up in the middle of a block. So you can't quite tell exactly what that solution is. So for that reason, I'm going to give you a second way of solving systems of equations that do not involve graphing. And this time today, this method is called the substitution method. So let's take a look at the same systems of equations that we used for graphing, this nice simple set that we did in our head, and then we did it by graphing back in the last video. And I'm going to show you another way to do it without graphing. So what we need to do is solve one of these equations for one of the variables. Now that means you have four options to start. You can solve the first equation for x or y, or the second equation for x or y. Now, sometimes there'll be an easier way if you choose one over the other, and I will explain that a little further in the next example. For now, I'm going to say let's solve the first equation for y. So what we do is we bring the x to the other side. Of course, you make it negative, and now that first step is done. So what we know is that y equals negative x plus 3. And what we'll do with that, we're going to substitute that in place of y in the other equation. Now you can take a look at that equation. You can see how we have all x's and now it's very solvable. Distribute this negative. That'll become plus x minus 3. Combine your like terms and continue to solve that two-step equation. Now once you know what x is, you can go back up to the beginning and substitute 2 in place of x, and you can solve it for y. So there's your x. You're going to replace it with 2 since we just found out x is 2. And we're going to continue to solve. Negative 2 plus 3 gives us 1. Now our solution will always be the x coordinate first. So we put the 2 there. And then the y coordinate goes second. So we put the 1 there. It doesn't matter which one we found first. We always put it x and then y. Now I just want to go back to the graphing method, and this was our last video. We solved the same example. We actually did it in our heads right here is what I'm showing you up in the corner, and then we did it by graphing as well. And you can see that the solutions did come out to be the same, both methods, so it doesn't matter which method you use for this one. Here's another example. So what I need to do is get one of these variables by themselves. Now I have 4 options. I always have 4 options. The first equation for x or y, the second equation for x or y. And in this case, you might notice the second equation is already solved for x, so you don't have to do any work if you choose to use that. That means we have an expression that equals x. X equals y plus 5. So in the other equation, I'm going to replace my x with y plus 5. And then what you see done is I distributed the 2, I combined my like terms, and I solved this two-step equation. So now I know y is 2. Now I will use that in the other equation to get x. Y is 2, we're going to replace it with 2, and that gives us x equals 7. And remember, our solution is always the x coordinate first, and then the y. You can check it the same way we did when we did the graphing method. Just take the x coordinate and the y coordinate and make sure that it satisfies the equation. Make sure it works. You can see it works in the first equation. And I'm going to replace x and y in the second equation, and it works also. Here's another example. So now I want to choose a variable to solve for, and I'm looking here, I see I have x or y, or this x or this y. Now, here's a little trick, and I said I would mention sometimes it's easier to do things one way over the other. I would pick the y without the coefficient, or with the coefficient of 1, because if you don't have a number other than 1, there'll be no dividing, and with no dividing, you will definitely not have to work with fractions. And I'm going to show you in a little bit what it looks like to work with fractions. So if we can avoid it, I always try to do so. So look for the variable with a coefficient of 1 if you have it, and if so, that is your best option. So to solve for y, that means I have to move the x over to the other side, and I'll make it negative. And now I have an expression that I can replace y with. Y equals negative 4x plus 1. So over in the other equation, you're going to substitute in place of y the negative 4x plus 1. And I know it looks a little bit longer, but it does have all x's, and now we can solve it. So we distribute the 6, and we combine like terms. 8x minus 24x is negative 16x, bring everything else down, and now it's a two-step equation. And I get x equals 1. So now that I know x equals 1, I just replace the x with 1 in the original equation. So negative 4 times 1 is negative 4, and then plus 1 is negative 3. So my final solution will be 1, negative 3. Now I'm just going to take a look at our answers, and I want to check them. I want to make sure that that satisfies both equations. So I've got 8 minus 18, or plus a negative 18, equals negative 10, and of course it does. So we know it works in the first one. Always check in both. I put the x value here, x is 1, y is negative 3, 4 times 1 is 4, 4 and negative 3 does give me 1. So it works in both. Now, here's an example that you will come across at some point. I just said a few minutes ago that I would look for the variable without a number in front, or with a coefficient of 1. But if you look at our 4 choices here, they all have coefficients other than 1. So sometimes there will still be an easier way than others. So I want to explore our options here. Let me show you what happens if you choose this y, and I'm just choosing randomly here. Now stay with me, because I'm going to show you an easier way when I'm done. I just want to show you what this may look like in case you run into it. If you choose y, you will have to divide by 3. And if you look at those other numbers, the 11 and the 5, dividing those numbers by 3 will definitely result in fractions. So I want you to see what this looks like. It's not that it can't be done. It's just that it causes more work than need be. So I solve this, and I get this expression to work with. Now it's not pretty, but I can still do it. I can substitute that expression in place of y. So the process is exactly the same. It's just I'm working with some fractions. I'll distribute, and you're probably just going to use your calculator to get those numbers I just got. You're going to combine like terms, and you're going to solve this two-step equation. And it does end up giving you 1 if you can make it all the way through it. And then once you get 1, you're going to sub that in like we always do, and I'll get negative 5/3 times 1 is just negative 5/3, and then I add 11/3, which gives me 6/3, or just 2. So my answer comes out to be 1, 2, but it was quite exhausting to get there. There is another way, and I want to look at it. I want to explore our other 3 options. If we choose this first x, I will have to divide by 5. And if you look at 3 and 11, you know you're going to get fractions. So we're going to end up with a similar situation as the one you just saw. If you choose the second equation for x, then you have to divide by 4. Now, 8 divides by 4 just fine. 2 divided by 4 will give you a fraction, although it won't be terrible. I'm just going to show you real quick what it would look like. 2 over 4 is a half, so you do have to work with a half, but it's not that bad. We do have one other option. If you choose this y, you'll have to divide by 2. Now, 8 and 4 do divide evenly by 2, so that would be our best option. That's going to be the way that doesn't give us any fractions at all. So you bring over the negative 4, or the 4x, it becomes negative 4x. You divide by 2, and you can see that you have this nice, easy expression, much simpler than the one we worked with before. You take that, you sub it in place of y, and you solve. So I distributed the 3. I'm going to combine my like terms, and I'm going to solve this two-step equation. Once I know what x is, I can replace it, and I can get y. And it turns out y is 2. So it's the same answer that I got the long way before, but it was a little bit easier because I didn't have to work with any fractions. So I know that may have sounded confusing, but if you practice this, I promise you it will get better. The substitution method always starts off looking difficult, and then as you go through it a few times, makes more sense. So don't forget to check out my other videos on graphing and elimination, and hit the like button if this helped you at all, and don't forget to subscribe. Thanks so much for watching.